Hey, everybody. Welcome back. Happy New Year. I hope you had an awesome break. This week for Module 1 of Quarter 3, we are going to begin studying inequalities that relate to equations where we left off first semester. So equations are where things are equal. Inequalities means things are not going to be equivalent. So our learning target is you'll be able to write and graph these inequalities. An equation uses an equal sign to show that both sides are the same or equal. An inequality shows that both sides are not equal. Okay, so hopefully you're familiar with these symbols. Greater than looks like this because we read it left to right, like we read a book. Greater than or equal to is the greater than symbol and then half the equal sign. That means it can include that number. Less than looks like that. Less than or equal to looks like that. And then not equal can be represented by slashing the equal sign. So we use these symbols to compare numbers, right? And so real quick, we'll compare these numbers down at the bottom. 4 is blank to 9. Well, 4 is less than 9. 5/10 is what to 45 hundredths? Greater than. -3 is further away from 0 on the negative side, so it's less than a -2. It's like worse, right? Losing $3 compared to losing $2. The next one, letter D, these are in fact the same because -6 and 1/10 is the same as or equal to -6 and 10 hundredths. Because I could just write a 0 right in the hundredths place, and it's the same. And then last, 12 and 4/10 compared to 12 and 4 hundredths. Well, tenths are bigger. Okay, all right. So here's a quick reference chart that I suggest printing off if you want to, or just coming back to, because when we are writing inequalities from different scenarios, we're going to want to be familiar with phrases like at most, no more than, at least, no less than, things like that. So kind of using that language piece to translate it to the appropriate inequality symbol. And then down below, the graphing, which I'll get into more detail here in a minute, but graphing all of these solutions that work for the inequalities, we use arrows and we kind of shade as a shortcut. And it'll make more sense once we start practicing it. But notice here at the bottom, these open circles versus these shaded in circles, right? That's going to make a big difference. So graphing inequalities. When we graph a number on a number line, we usually fill it in, right? It's included. But sometimes if it doesn't include that number, not sometimes, but when it doesn't include that number, we want to leave that circle open. So the symbols that are attached to this idea is when it's included, we're talking about the less than or equal symbol or the greater than or equal to symbol. When it's not included, we're just talking about the numbers less than that point on the number line or greater than that point on the number line. So over here on the right, when we're talking about x being less than or equal to the number 5, that means x can be anything less than or equal to 5. That's a lot of numbers. Think of all our rational numbers, all the decimals and fractions that live in between our integers. So how to graph this is I want to mark where the 5 is. Okay, so x is less than or equal to 5. It is including the number 5. Notice that I'm filling in that circle because it includes the number 5. And then I'm going to just shade to the left, right? Because all of these numbers are solutions to this inequality. We sketch it because I don't know about you, I don't want to sit down and list all of the numbers less than 5. Do you? That's like an infinite number of numbers. Okay, let's practice this a little bit more. Starting in the upper left, k is greater than 11. So k is some number greater than 11. I'm going to mark the 11 on the number line. Open circle, it doesn't include the number 11. And all the numbers greater than it would be to the right. Okay. Beneath that one, x is greater than or equal to 4.5. Okay, so where's 4.5? It's right here. It includes 4.5, so I shade it in. And all the numbers greater than that would be to the right. Okay, upper right corner. 12 is greater than or equal to f. So we can also rewrite this if it helps you to have the variable written first and think about it that way. Feel free to just kind of flip it around and think about it. It helps me for sure. So f is less than or equal to 12. That's allowed. So all the numbers less than or equal to 12 would look like this. It includes 12, and all the numbers less than it, is all the way to the left, all of those. And then this last one, m is less than -7. So open circle because it's just a less than symbol, and less than would be all the numbers to the left, right? They're getting smaller and smaller to the left. And that's how we graph the solutions to inequalities. So let's kind of test some solutions out and see if they work. So determine whether each value makes a true statement. Number one, k plus 8 is greater than or equal to 19. So would this be true if k is 11? Let's try it out. If k is 11, I'm asking myself, right, question mark, would this inequality statement be true? Well, 11 plus 8 is 19. So is 19 greater than or equal to 19? Yeah, it's the same. So that's true. Now, if it did not have that half equal sign, right, and if it said 19 is greater than 19, that wouldn't be true. Number two, 12 is greater than f. Would this be true if f is 3? Is 12 greater than 3? Yes. True. Okay, last one. 3 is greater than d. If d is 3, would this inequality statement be true? Is 3 greater than 3? No. It's equivalent to it. It's not greater. False. That statement is false. Okay, and then writing inequalities to represent situations. When we write the inequalities, don't forget, just like with equations, we want the unknown to be the variable. So letter A, Sam owes at least $12. So X will stand for what he owes because we don't know that, right? We just know he owes at least $12. So he could owe $12, and this means that he could owe $12 or more because at least is like the minimum. So X is greater than or equal to 12. Letter B, you must be under 18 years old to play in the youth league. So you must be under 18. So your age, what we're talking about, I'll just choose X again, must be under 18. It doesn't say that you have to be like 18, including 18, right? You have to be under 18. So it would be your age has to be less than 18. Letter C, in order to drive, you must be 16 years old. That's a minimum, right? You have to be 16 years old, and you can also be older than that. So again, we're talking about age. We'll just choose X. In order to drive, you must be 16 years old. So you have to be greater than 16, or you could also be exactly 16. And then last one, a commercial can last no longer than 30 seconds. That's like saying 30 seconds is the max. So X has to be, let's see, less than, and thinking if it could include it. A commercial can last no longer than 30 seconds. I think it could include 30 seconds exactly. Maybe that's like the last amount of seconds it could be. Okay, so no longer than. All right, and that is all about your intro to inequalities. And in the next couple of weeks, we kind of take this idea a little bit further and we solve for inequalities. But the big idea is inequalities have multiple solutions. Okay, whereas equations have exactly one, only one solution that works. Inequalities can include so many numbers that work.